So for this example, this one is actually going to have simultaneous equations in it. So we're still going to be using the Suvat equations, but we'll end up with two equations for simultaneous, and then you can then solve them that way. So again, the first thing I'm going to do is just highlight the bits that are important, because again it is very wordy, and then I'm going to draw a diagram afterwards. So we're told there's 3 posts. We've got P, Q and R, and they are in that order, which is really important. Okay, the distance from P to Q is 45, and the distance from Q to R is 120. Okay, the car is moving at a constant acceleration, so that means it's going to be the Suvat. Okay, and we don't know what it is, they've just called it A for acceleration. The speed of the car when it passes P is U, so that means that the starting velocity is going to be U. The car passes Q after 2 seconds of passing P, and the car passes R 4 seconds after passing Q. Okay, so they're going to be the bits that are going to keep changing for the Suvat. So again, I'm just going to draw a quick diagram. Ooh, lovely straight line. Okay, so you've got P, you've got Q, and you've got R. So between these two are 45 meters, because that's what it says here. Between Q and R, the distance is 120 meters. We know that the velocity at P is just U. And we know the acceleration the whole way is just A. Okay, so I'm going to start with the PQ one. Okay, so Suvat. Move that bottle, that's irritating. So the distance is 45. The initial speed is U. V we don't know. The acceleration we know is A, and we're told that the time is 2 seconds from Q to P. I'm just going to add that on here if I do it in a different colour. So from there to there it's 2 seconds, from there to there it was 4 seconds. Okay, so add 2 there. So here's our Suvat equations. So the one that uses the S, the U, the A and the T is going to be number 2. Okay, so I always like to write it out just to start off with. Okay, and then we can sub it in. So S is 45, then it's U times T, so U times 2, plus a half times A times 2 squared. And then we can just simplify it, so that's 45, that'll be 2U, that's 4, so half of 4 would be 2 still. Okay, and we'll get that. So for the next bit, so I'm going to go from P to R. The reason why is if we just go from Q to R, we don't know what U is. We're not going to have a U in it, because the U is what the speed was at P, not at Q. Obviously the speed at Q is going to be, well, we don't know what let's say the acceleration is positive, so it means it's speeding up. That means U will be getting bigger, okay? So I'm going to go from P to R. Again, I'm just writing Suvat. So the total distance of those two added together, so that's 165. The total time will be the 2 and the 4, so that'll be 6 seconds. The acceleration is A and the initial speed is U. So we're going to be using the same equation as this. Okay, and again we just sub it in. 18. Okay. So then we have the two simultaneous equations. We've got this one here, and we've got this one here. Okay, so I'm going to multiply this one by 6. I'm going to make the u's the same. So we would have 270, but I'm going to check that. 45 times by 6, yes. 270, that would become, I should have times it by 6. That's why it's looking weird. Start again. Okay, should be times them by 3. Okay, because I want that to be 6u, so if it's 2u at the moment, we're times by 3. So 45 times by 3 is 135. That would be 6u, and that would be 6a. Okay, so I'm just going to write this one and then this one underneath it. So 165 equals 6u plus 18a, and then 135 equals 6u plus 6a. Okay, we can then subtract them from each other. So we're left with 30 here, and then we're left with 12a there. Divide by 12, which gives us a 2.5 minus 2. Okay, so that's the acceleration, and then just like normal simultaneous, you'd then put it into another equation. So I'm actually going to go back to this one here. Okay, so we know that the acceleration is 2.5, so 2 times 2.5 would give you just 5. And then you can just solve it, so minus 5 from both sides, so you'd get 40 equals 2u, and then divide both sides by 2, which gives me that u is 20 meters per second.